Hello, welcome back to another video. Today we're going to be going through the Edexcel Paper 3 Foundation for 2024. If you've got any specific questions that you're looking for, have a look in the link description and you'll be able to find your link there and you can go straight to that question. But without further ado, we're going to head straight into the paper, and if you want to run through the whole thing with me, we can do it now. Cool. So first thing to note, paper threes, they're calculators, right? So we're going to be using our calculator as much as possible for this. But yeah, let's dive in. Let's see what we can do. So first of all, can you write 23% as a fraction? Easiest thing to do is go, cool, decimals, they're just the number over 100. So potentially one here that you just have to know. But yeah, 23 over 100 to get us started there. Next up, 800 centimeters into meters. Well, 100 centimeters is 1 meter. You might even be able to see a ruler, and it will tell you that. So if we've got 800 centimeters, this is going to be 8 meters. Write down the value of the 3 in the number 62,837. This is going to be the tens, or you could put 30. Next up, simplify 7a plus a minus 5a. All right, remember that this is your first bit of algebra, so you want to be comfortable with these, but algebra is just like, they're actual objects. A's are footballs or mountain bikes or whatever you want to think about. So we've got 7 footballs plus a football minus 5 footballs. How much would we end up with? Well, that would be 3 A's. Cool. Write the following fractions in order of size. Cool, smallest to biggest. Now, either you'll know what these are as decimals or percentages. That's a really nice way to start. But if you don't, it's always nice to scale up so they have the same denominator. So here we've got a quarter, 2/3, and 1/2. All of these numbers go into 12, so we could rewrite them as twelfths. So a quarter multiplying the top and bottom by 3 would give you 3 over 12. 2/3 multiplying the top and bottom by 4 would give you 8 twelfths. And a half multiplying top and bottom by 6 would give you 6 twelfths. And now it's a lot easier to compare your numerators. So the smallest is a quarter, then the half, then the 2/3. Nice. A map has a scale of 1 centimeter, representing 4 kilometers. On the map, the distance from town A to town B is 8 centimeters. Find the real distance. All right, if 1 centimeter is 4 kilometers and we've got 8 centimeters, all right, let's just write this out. Right, we have to multiply this side by 8. So we're also going to end up multiplying this side by 8. If you're feeling a little bit nervous with your mental maths, might as well just slap this into a calculator. But that would give you 32 kilometers. 32 there. Cool. The real length of a road is 10 kilometers. Work out the length on the map. Okay, fantastic. So if 1 centimeter is 4 kilometers, and it's saying we've got 10 kilometers, what have we multiplied to get from 4 to 10, right? Or in other words, what is 10 over 4, right? Almost going the other way. Well, this is 2.5 times. So 2.5 on this side would give you 2.5 centimeters. And this one, you can do by just looking at it and hoping that it's okay and going, how many times do I have to multiply 4 by to get to 10? Maybe the half would get a little bit confusing. So you can sort of rearrange your equation going 4 multiplied by some unknown equals 10, meaning that your question mark is equal to 10 over 4. That's where this idea came from. Cool. Moving onwards. Okay. So here we've got a graph. We've got a bar chart. And each bar represents a method of getting to school. And our first question is, write down which method is the mode. Well, the mode, the way that I like to remember this is that MO also matches the word most. So the question is, which one of these is the most? And the answer is the bus. More students walk to school than cycle to school, but how many more? All right, so here we're looking at how many people cycled, which is 3, and how many people walked, so that's this bar here, that's 8. What's the difference? 5. Wabam. Excellent stuff. Question 8. Aisha was born in 1993. There was an election in the year of Aisha's 18th birthday. There is an election every 5 years. Will there be an election in 2030? All right, so here we're wondering, well, she's born in 1993 and 18 years go by. What year is it? Well, to do this, we're going to add 18 to 1993. And if we were to do that, add 10 years gets us to 2003. Add another 8. Well, we're in 2011. Cool. And then that means that elections every 5-year increments from here. So the next one will be 2016. Next one will be 2021. The next would be 2026 now. And then we're just going to miss it, 2031. Not there. Cool. So no. And you might even be able to spot this straight away from 2011, realizing that if you're adding 5s, you can only go up in 5 or 10 increments at a time. Cool. On to question 9. Lucia is going on a skiing holiday. The cost of a ski hire is £26 a day. The cost of the lift pass is £45 a day. The cost of the ski lessons is £23.50 per hour. Okay, so we've just got a multitude of different things here to figure out. What are we figuring out? So Lucy has enough money to pay for the total stuff. Cool. So we've basically got a list of things that we need to buy, right? So let's work through each one by one. So first of all, let's look at the ski hire. Ski hire for 5 days. Well, if it's £26 for one and we're doing it for 5, we're just going to multiply those together. Cool. Not going to worry about getting this wrong, but yes, 130. Then onto the lift pass. So this is the second one. So a lift pass per day is £45 and we want it for 4 days. So 45 times 4, it's going to be 180. And last but not least, we've got ski lessons at £23.50 an hour, slightly different unit here, but we're doing it for 8 hours. So no need to convert any units or anything just yet. So, £23.50 times by 8. Awesome. Let's see what that becomes to. £888. Now, definitely make the most of having your calculator in this question. I know a few of you would definitely enjoy just, hoping for the best and doing all the numbers that way. But yes, add all of those numbers together in your calculator, double check, and you should get 498. So yes, she definitely just has enough with £2 to spare. Fantastic. That might even get her a snack. Awesome. On to question 10 now. We've got a circle, and on the diagram above, draw a radius. Okay, so these ones are probably, if you haven't revised your circles, you're going to just be stumped with these, but a radius is the distance from the center to the outside. There it is. And the next one, another circle, write down the mathematical name for a straight line inside the circle. Okay, so this isn't a diameter. A diameter must go through the center of your circle. Any line that goes from either edge but doesn't go through the center is known as a chord. Awesome. Question 11. There are 8 episodes in a TV series. Each episode lasts 45 minutes. Work out the total time that the 8 episodes last, and we want our units in hours. Right, we're doing a minute to hour conversion here. I'm going to lean towards converting first. So, well, how much of an hour is 45 minutes, right? If we wanted 45 minutes in hours, well, how do we get it? And the way to do it is to go, well, this is a fraction. How many minutes is it out of the total minutes in an hour? Well, that would leave us with 45, the amount that we have per episode, out of the total amount of minutes in an hour. Now, if you were to put this into your calculator, no need to worry about simplifying that on the fly, right? But you'll get 3/4. And maybe you might even know this, right? 3/4 of an hour is 45 minutes. You might even hear people mentioning that to you. So here we go. Now we're in hours. Each episode lasts 3/4 of an hour. So instead of having to do any crazy maths at the end, we can just do 8 times by 3/4 on our calculator. And whatever that gives us, we are very happy with. 3/4 gives us 6. Nice. Next up, prime numbers. Name some prime numbers between 20 and 40. So prime numbers are numbers that are only divisible by 1 and themselves. They've got no other factors. So for example, 2 is a prime number. It can be divisible by 1 and 2. 3, once again, 1 and 3. But 4 is not a prime number because it's also divisible by 2. Okay? So that's how we're going to distinguish. So if we were to keep on going, I'm going to run through all of them. Why not? We get 5, 7. Maybe do this with me. See if you can figure out the next one before we'll do it. There we go. It's going well. Not 21. A lot of people are going to go, ooh, 21. 23. 27. No. Careful with that one. 29. Keep on going. 31. 33 is in the 3 times table. 37. Not 39. Oh, even I was almost getting caught out there. So yes, you've got 4 to choose from. 23, 29, 31, or 37. So any combination of 3 of those is fine. Question 13. James asks students in Year 10 and Year 11 to name their favourite language from French or German or Spanish. The two-way table shows information about the results. Complete the two-way table. So our objective here is just to fill in every box we can. So to begin with, we're looking for ones that are only missing one box. Here's one, for example, or we could even go in up here with this one. So we've got a few different options to start with, but I'm going to start with that Spanish in Year 11 spot. So to get that, 67 minus 34. So we get 33 in here. Remember that the ones on the outside, these are totals. So this number plus this number is going to give this number. But equally over here, notice that we've got sum total of Year 10s plus the total of Year 11s gives the total students all together. So we can also work out that one. 207 minus 113 gives 94. And wonderfully, this is actually going to open up. Both of these moves have opened up us to find the German and French-speaking people there. So let's start with the top one. So to get that Germans in Year 10, we're going to do 94 minus 34 minus 33, giving us 27. And same for finding the French-speaking students in Year 11. We've got 113 minus 33 minus 45, giving us 35. Fantastic. And now, last but not least, we can figure out these 2 remaining ones at the bottom. So let's start with the French. 33 plus 35 is going to be 68. And 27 plus 45, oh, very nearly went wrong there, is 72. And you know what? There's no harm at all in just double checking that all the numbers add together. I'm going to just quickly add horizontally here for the totals and just double check that all of our numbers are adding up there. So 72 plus 67, 207. Boom. That works. So always good to check when you can. Ooh. The table gives information about the drinks people ordered in a cafe. 30 people ordered coffee, 10 people ordered a hot chocolate, and 50 people ordered tea. Draw an accurate pie chart. Ooh. Okay. So our objective first is to figure out, well, what is the degrees that each person is going to have? Then you're going to have to get your compass out and actually measure that out so it's precise. So let's figure this one out. So you'll know that there are 360 degrees in a circle. And we can also work out the total number of people who are partaking in this experiment. It is 90, right? So if there's 90 people altogether and we need a total of 360 degrees, well, we just have to multiply everything by 4. Okay? So 30 multiplied by 4 would give 120, 10 by 4 gives 40, and 50 by 4 gives 200. Now, it would be your objective now to figure out what these would be, but I'm just going to sketch them on. Your 120 would roughly be here, and this would be your coffee. That'd be 120, and then you'd have 40. You'd have 40, which would maybe take us to, I don't know, somewhere over here. And this would be your hot chocolate, and then everybody else, this would be your 200, and this would be T. Nice. And you can do this in a different order, right? It doesn't have to go coffee, hot chocolate, tea. It could go coffee, hot chocolate, tea at the bottom, right? It doesn't really matter, but these angles do have to be correct. Which is greater? Cool. Well, once again, thankfully this is a calculator paper, so let's not worry too much about this. I'd suggest that we turn both of these either into fractions or decimals. For peace of mind, I'm going to turn both of these into decimals. So 15% is going to become 0.15 dividing by 100, and 20% is going to become 0.2. Okay. Now, to figure out what the value is of both, we can just do 0.15 times by 88. That gives us a value. And over here, we can do 0.2 times by 62. So using our calculator, we're going to get 13.2 over here, and over there we're going to get 0.2 times by 62. It's going to give us 12.4. So 15% of 88 is larger than 20% of 62. I'm also sure that many of you might have gone for the old like find 10%, find 5% method as well. I'll run through that quickly. So if you found 10% of 88, that would be 8.8. And therefore 5% would be 4.4. Add those together, lo and behold, you get the same thing. And over here as well, you can find 10% dividing by 10, which would give you 6.2. Then to get your 20%, all you're going to do is times this by 2, and you're also getting 12.4, right? So you can do it either way. Question 16. M times M times M times M. How many m's have we got? How many times are they multiplying? This is m to the 4, okay? So yes, multiplying a piece of algebra by itself that many times is what a power is. In a competition, a player gets 5 points if they win a game, 2 points if they draw, and 0 points if they lose. Amy wins X games and draws Y games. Write down an expression in terms of X and Y for the total number of points she scored. Cool. Well, if she wins X games and she gets 5 points for every winning game, she's going to get X times by 5 points, right? So imagine this like a machine. If I've won 4 games, I'd replace X with 4 and multiply it by 5, 20, right? We can then repeat this and add it for the drawn games. So this is going to be Y multiplied by 2. The same logic applies. Now, if we wanted to write this more concisely, we'd say 2y plus 5x, or the other way around, so 5x plus 2y. No, it doesn't matter. Question 17. Here is the ingredients needed to make 20 shortbreads. She wants to make 30. How much of each ingredient will she need? Well, if this is the amount she needs for 20, well, we know that to make 10 biscuits, she's going to need half of all of these ingredients. So that would be 60, 100, and 25. Therefore, to make 30, we can just combine what she needs for 20 with what she needs for 10. Right, and this is going to leave us with 120 plus 60, 180 grams of butter, and then 200 plus 100, 300 grams of flour, and last but not least, 50 grams of sugar plus 25 grams gives 75 grams. Nice. Okay, question 18. On the grid, rotate the shape by 180 degrees, about 0, 0. So this is one of those where you get your tracing paper out, probably stab it about there, shade in your trapezium, and then move your paper around to the other side. But say if you didn't have your paper, there is alternative ways. I would suggest that you usually pick a point, right? I'm going to pick this point, and I'm going to say it's 1, 2, 3, 4, up, and then 1 to the right. Then if I was to rotate it 180 degrees, well, you're flipping both of your movements around. Think about it. If that was like an axle or something, it would be moving around my point here, and it would drop down here. Be 1, 2, 3, 4, and 1 to the right. Right? Think about it. It's moving around. And that would mean that we know where this point is. And using a bit of thinking about how the shape has also turned, we can actually plot it on as well. So it'd be there, 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 and there. And there's our trapezium. Ooh, a bit sketchily drawn by me there, but there you go. Nice. Mike was asked to reflect shape A in the line x equals 3. Mike's answer is shown on the grid. Explain why he's wrong. Wow. Has he reflected in the right line? No, he absolutely hasn't. X equals 3 is here, right? That's where x equals 3. Look at your number line. That's the x-axis. That's where x is 3. So all the points vertically here are x equals 3's. So when he had shape A, he should have reflected it this way. What he's done is he's reflected in y equals 3, this line. Nice. Question 19. Here we're going to be looking at the graph of y equals 3x minus 2. And we want to plot it between minus 2 and 3. But we've not been given any values or a line or anything. So we're going to have to look at our equation up here and figure out what it's actually going to do. Now my advice is that these equations, any type of equation you see, be it linear or quadratic, you're always just plugging in x coordinates. That's what it is. It takes an x coordinate and it spits out a y coordinate. So let's treat it as such. We're going to make a little machine or a table just to realize what happens when we pass in different values of x. 1, 2, 3. There we go. So we want to pass in all of the values between minus 2 and 3 and just see what happens when they come out the other side. So you can start wherever you want, but I'd suggest it's actually a little bit nicer to start with the positive numbers, and in particular, starting with 0. If I was to pass 0 into 3 times 0, remember these are replacing your x value, well, 3 times 0 is 0, so I'm just going to end up with minus 2. Then for 1, I'm going to have 3 times 1 take away 2, which is going to give us 1. Once again, 3 times 2 gives 6, take away 2 gives 4. And with linear equations, i.e. things that are in this y equals mx plus c form, you will notice a regular change between your y coordinates, right? Here we're seeing a regular plus 3. So actually there is a point where you can just look at what you've got and figure out what the rest of them are going to be. But it's always worth checking those. I can let you do that in your own time. But yes, from here, you then just go and plot all of these on the graph where you need them. I'm going to do this hopefully quite quickly, but it should form a straight line equation. And if it doesn't, well, something's up. Something is up. Notice as well on this graph, we've got a different rate of increments on our x-axis as we do on our y-axis. Our x, it's 2 squares to every one move, whereas vertically it's only 1 square for each move. So that catches people out quite a lot. Yeah, there we go. That looks fairly straight. I'll do my best to connect these. Oh, there we go. Cool. Now on to question 20. Oof. This one is looking a little bit harder, so let's see what we can do here. We've got 2 isosceles triangles. It says right at the start of the question, so we need to bear that in mind and think about, what's interesting about isosceles triangles? Well, 2 sides are the same length, but also 2 angles are the same sides. So this is probably going to come in useful somewhere, or else the question wouldn't be to do with isosceles triangles. Nicely, it's kind of reminded us that the sides are the same length here. AB is equal to BC, which is equal to CD. Nice, they've given them all of these lines all the way through. That's what those mean. Now, angle CAB, that's this one we've been given it, is 81 degrees. Cool. And then we're told that angle BCD, where's that? BCD that's here, is 4 times the angle ABC, that's over here. Cool. So I'd say that our objective at the moment is just to start figuring things out. To begin with, we've got this one up here. Now, picture that isosceles triangle, and if you rotated it round, these two are going to be the ones that are the same. And then you're left with this one up here. You'll remember as well that triangles hopefully have 180 degrees within them, so different from a quadrilateral, which has 360. So a little bit of maths here will let us realize that this angle here is going to be 180 minus 81 minus 81, leaving us with 18. Now, that means we've found this angle ABC. That's down here. This is angle 18. And to get angle BCD, I'm going to do it in red up here, BCD, that's up here, we just need to multiply it by 4. So what's 18 times 4? Let's have a look. 18 times 4, there it is, 72. Now once again, if you were to like rotate this BCD triangle round a little bit, you'll realize that this bottom two, these are the bottom two, and they're going to be the same size. So here we've got to think a little bit more outside the box. We're going to go, well, this angle X and this angle X plus the 72 is equal to 180, right? So 180 minus 72 equals 2x's, right? In other words, we've got 108 is equal to 2x, and x is therefore equal to 54. Cool. Very nice. So from here, the size of angle ABC as a ratio to the size of angle CBD. Cool. So ABC was this one, it was 18. And then angle CBD, that's this one down here, is 54. How would we simplify both of these? Well, you might be able to spot it super quickly, but I'm going to say let's just divide by 2. 9, and then we've got 27. You might also spot it from here, realizing both of them are divisible by 9. Maybe you would, maybe you wouldn't, but yes, 1 and 3 is the final one. So just to be super clear, that was a divide by 2, then divide by 9. Cool. You could do it in one if you realize that 18 and 54 are both divisible by 18, but who knows their 18 times table. 5 marks for that. Lots of marks to be get up there, so do take your time with this one. Isosceles triangles being not oriented the normal way can be a bit confusing, but the tip for remembering which sides are the same is it's the two sides that border the length that isn't the same. Or, alternatively, the two lengths that are the same touch at the angle that's unique. Okay, question 21. Factorize 6x minus 15. So to do this, we want to figure out what number is similar between 6 and 15. What's the biggest number that goes into both 6 and 15? Well, that's going to be 3. So we're going to take the number 3 outside, and we're going to go, 3 times what gives me 6x? 2x. 3 times what gives me minus 15? Minus 5. Done. Same idea for this one, but this time we're going to be factorizing algebra. We don't have any common numbers in m squared and 5m, but we do have a common bit of algebra, m. So we can pull one m to the outside. They both share an m. Why couldn't I take an m squared out? Well, 5m doesn't have a squared, right? But here we go. So m on the outside, how do I get from m to m squared? Multiply by another m. And how do I get from m to 5m? Multiply it by 5. Now you can always check these by expanding these back out. A lot of people have a preference for expansion rather than factorization. Okay. We want to find the highest common factor of 63 and 105. So the highest common factor is the biggest number that goes into 63 and 105. Okay? So what number in its times tables sees 63 and 105? Now, sometimes people can do these just by looking at it or a bit trial and error, but if you want the foolproof method, that's what I'm going to do. We start by finding the prime factors and then populate a Venn diagram and the prime factors that are common to both 63 and 105 multiplied together will give you the highest common factor. So let's work through these together. 63. So the way to break these down is to think about what numbers go into these numbers. But when multiplying, for example, here, I think the fastest one most people would think of is actually 7 and 9. And then you can break this down just that little bit further. 9 isn't quite prime yet. You've got 7, 3, and 3. So we can write 63 as 3 squared times by 7. Then over here, we've got 105. Well, this one's clearly in the 5 times table. It might take you just a minute to figure out that this is actually 5 times 21. And then you can realize that this breaks into 3 and 7. Cool. So 105 is 3 times 5 times by 7. Now we can draw our Venn diagrams. And what we're looking for is the values that are in, or the prime factors that are in both. So we've got 63 and 105. What prime factors are in both? Well, there's 1, 3 and 1, 7. 1, 3, 1, 7. Just to finish labeling out, we've still got one more 3 for 63 that would go on the left-hand side. And for 105, we've got an extra 5. But to get our highest common factor, we take these two numbers and we multiply them together. 3 times 7, which gives us 21. Nice. And if you're ever looking for your lowest common multiple, well, that's when you take all of the numbers. You take all of them in there and you multiply all of the ones you can see together. So 3 times 3 times 7 times 5 is equal to your lowest common multiple. That's the first number that's in both the 63 and the 105 times table. Cool. Next up, we've got some standard form. So here we're going to be thinking about what 5.3 is times by 10 to the 4. Cool. So I always like to give yourself some spare zeros to play around with. And we're multiplying this by 10 to the 4. What's that going to do? Well, actually, all it does is it moves our decimal point 1, 2, 3, 4 to the right. Okay, our new decimal point is going to be over here. Therefore, our final answer is 53,000. And there you go. Nice. And a very similar idea plays with doing it to negative powers. So if we've got 7.4, this time let's give ourselves some zeros to the left-hand side to play around with. We're going to be doing a very similar thing. If we did... we're just going to move 5 to the left here. So 1, 2, 3, 4, 5. There we go. Cool, and you can always check these on a calculator as well. 7.4 times by 10 to the minus 5. And you can sometimes, they might like have an engineering button on them. But yeah, you'll want to just be very, very careful that these are all correct. There you go. So 0.00074 would be our answer here. So 0.123474. Cool. Now we've got this thing. Oh, this is particularly weird. Once again, it's a calculator paper. I don't see any harm in just typing this into your calculator and seeing what it gives you. But say you didn't have a calculator and you wanted to think about how you'd approach this. Well, you could say that this is kind of like 9.7 plus 9.45 times 10. And then all of this, right, has a times 10 to the 6 just on the side. So if we had 9.7 plus 24.5, we're left with... Oh, I'll get a calculator out, which, you know, I'm sure you're going, well, come on, you could just type in the whole thing in the first place. But this would give 34.2, and this would all be times 10 to the 6. And times 10 to the 6 is famously a million. So you're going to have 34,200 like that. And let's just double check through it again just to make sure everything's okay there. Times 10 to the 6 plus 2.45 times 10 to the 7. Yeah, super easy to get these ones wrong. But yeah, how many zeros have we got at the end of this thing? 3, 4, 2, and then 5 zeros. Boom. Got that one right. Nice. Very easy to get these ones wrong. And yeah, you could be super critical of those zeros, but you're in a calculator paper, use it. Okay. Here we see a solid triangular prism. Cool. We're trying to draw the side elevation, looking at it from the arrow that she's drawn. Explain why her drawing is incorrect. Well, the logic is that in this triangular prism, we've got this diagonal height as 4. But she's drawn the vertical height as 4. When in reality, the vertical height is here. We actually don't know what this is just yet. It's never explained. So her assumption that it's got a vertical height of 4 is wrong. And I just summarize that by saying the vertical height cannot be assumed to be 4. We'd actually have to go about working out what it actually is, which would be possible. Maybe there'll be a part B on the centimeter. Yes. Draw a plan. Cool. So we've actually been asked to draw the plan for this. Remember that a plan is the word for the top-down view. So imagine that we were up here looking at our thing, and here we are. We're like looking down, eyelashes, whatever, and we're trying to figure out how big it's going to be. Well, all we're going to see is this base. We're going to just see this shape down the bottom, the 6 by 7. So that's what we're going to have to draw. A 6 by 7 grid. So we've got 1, 2, 3, 4, 5, 6, and we do this across 1, 2, 3, 4, 7. Oops. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Yeah. Cool. And it can just be a sketch like that. Super simple. Bish bash bosh. On to the next one. Question 25. A company has 25,000 workers. The number of workers increases at a rate of 6% per year for 3 years. Calculate the total number at the end of the 3 years. Fantastic. Well, this is known as compound interest. Each year, you're going to increase the amount that you have by a further 6%. Now, there is a formula in the formula sheet for you to figure this one out, and it essentially says your initial amount gets multiplied by 1 plus some value r. This r is the interest rate. Importantly, this is as a decimal. And then what do we want from here? It's all to the power of the years, the number of years. Okay, so if we take all of our values and see what happens, we've got 25,000 multiplied by 1 plus our interest rate, 6%, but as a decimal, 0.06, all to the power of number of years, 3. Boom. Right, let's type that in and see what it gives us. Multiplied by 1 plus 0.06 to the power of 3. There it is. 29,775.4. So total number of workers, I'd assume that they want you to round to the nearest person. So 29,775. Very nice. Yeah, nice question for just 4 marks. That's a lot of marks for that. Yeah. Okay, next up. Habib has 2 identical tins. He puts 600 grams of flour into one of the tins. The flour fills the tin completely. The density of the flour is this. Oh, I can see where this is going. This is density equals mass over volume question. So let's start by writing that down. Density equals mass over volume. And what have we got here? We've got 600 grams. And the density of the flour is 0.6 grams per centimeters cubed. Okay, cool. So all the units are lining up okay here. We've got 600 grams. This is in grams as well. Let's see what happens over here. Maybe not to worry about it, but we just want to see what it's doing. Habib puts 600 grams of salt into another tin. The salt does not fill the tin completely. Okay. The volume of the space in the tin that is not filled is 700 centimeters cubed. Okay, I can see what's happening. So this is kind of like our part A up here, and this is more like our part B. So in the part A, we're given a mass, 600 grams, and we're given a density. Now, using our formula, we can figure out a volume. A volume is an amount of space that's filled by something. So if we do the mass of something divided by the density, we're left with the volume. So in our case, we've got 600 grams divided by 0.6. This is going to give us 600 divided by 0.6, 1,000. 1,000. And our units here are hiding away in the density, so 1,000 centimeters cubed. Okay, fantastic. Now, looking into part B, we're given, once again, a mass. So our mass for part B is 600 grams. But we don't fill the tin completely. The volume of the space in the tin that is not filled is 700 centimeters cubed. So we can figure out that the volume that remains is going to be, well, we know that the volume in the tin is 1,000. We know that 700 are not filled, so it must be 300 centimeters cubed. Okay. Putting this together, we can figure out the density by dividing mass by volume. So volume, and for us that's going to be 600 divided by 300, which gives 2. Nice. So to summarize, salt is more dense than flour. Okay. Next up, question 27. We've got a probability tree, and we need to just populate the probability tree and finish up everything here. So Tim has 2 biased coins, biased coin A and biased coin B. He's going to throw both the coins. And the probability that A will land on heads is 0.6. The probability that B will land on heads is 0.55. So we're treating each throw and each coin as its own event. And it must land on heads or not heads, right? I know a lot of you can be like, it can land on its side. Coins don't land on their sides, right? So if it lands on heads, it's got a 0.6 chance of landing on it. And we know that the probability must always sum to 1, right? Because if it doesn't sum to 1, then you've got some spare probability lying around. You can't not have it sum up to 1. So therefore, for coin A, it has a 0.4 chance of landing not on heads, right? To ensure that it sums up to 1. And both of these trees are coin B. So 0.55 leaves 0.45 spare. A lot of people sometimes get confused with this tree down here. Like I said, it's just coin B again, but it's assuming that coin A landed on not heads. So it's just telling the story, but nothing changes for the probabilities here. So Tim throws coin A once and he throws coin B once. Work out the probability that both coins land on heads. And this is why the probability tree is useful. We follow the things that we want. Here we go. And think about it like this, right? We're following this story of it landed on heads once, which had a 0.6 chance of happening, and then we want it to land on heads again. We want to have 0.55%, or not 0.55, not percent, of the 0.6. In other words, we want to do 0.6 times by 0.55. Bam. And that gives us 33 over 100. Nice. Conceptually, this can be a little bit weird to get your head around, but if you think about 2 non-biased coins, right? Probability of a half landing on heads or tails. If you want to think about the probability that a non-biased coin landed on heads twice, you'd go, well, I want a half for the first one, and then it'll be half again. But to follow that path, it would be half of a half, right? It would be half of the original half, giving you a quarter. It's the same logic here. That was actually 0.5 multiplied by 0.5 in that example. Okay, on to question 28. And here we've got a swimming pool. It's in the shape of a cylinder, and it's got a radius of 100 and a depth of 30. The pool is currently empty and it's filled at a rate of 250 centimeters cubed per second. Work out the number of minutes it takes to fill the pool completely. Okay. So yeah, lots of people are going to trip up on minutes here, realizing that it fills in seconds. So we're going to have to be pretty clever with how we approach this. But first, we're going to have to figure out the volume. Now, the volume of a cylinder is found in the same way that you find the volume of a prism. It's found by finding the area of the shape at the top and then just multiplying it by the depth. Cool. So in our case, we need to find the area of the circle. So let me just write this clearly. So the area is going to be pi r squared. You're going to need to remember that formula, right? And then pi times by this 100 squared. What's that going to give us? That's going to give us, big number. 100 squared is 10,000. So we've got 10,000 pi's centimeters squared as our area. Then to get the volume, we're going to do that 10,000 pi. I'm going to multiply it by 30. So let's do that. So 10,000 pi multiplied by 30 is going to give us 300,000 pi's. Or in other words, if we turn that into a decimal, we get 942,477.8 centimeters cubed. Okay, fantastic. Now we've got two things that we can do here. We now know the whole volume. And we can figure out, how many seconds it's going to take by figuring out how many times that 250 goes into this 942,000. Or we could start by figuring out what the rate is that it's filled at per minute. That's going to make our calculation a little bit easier, I think. So if it fills 250 centimeters cubed per second, and there's 60 seconds in 1 min, well, we're going to have to multiply this 250 by 60. And that'll tell us how much we're putting in the pool a minute. So 250 times 60 gives 15,000. Cool. So we've got 15,000 centimeters cubed. And this is per minute. Okay. So if we fill at 15,000 centimeters cubed per min, our calculation is actually fairly simple. We're going to take the 942,477.8 and divide it by that 15,000. So 942,477.8 divided by 15,000. And that calculation in essence is just going, how many times does it take this 15,000 to happen until you've hit that capacity? And our answer to the nearest minute is 63. Nice. Cool. And then, on to our final question. Question 29. Calculate the value of W when t is equal to -5. Some fairly nice algebra here just to finish up. W equals 40 minus -5 squared. So careful with this bit. You've got 40 take away. Well, -5 squared is like saying -5 times -5. We're just going to give you positive 25. And then you're still doing 40 minus 25. So W is equal to 15. Cool. Nice one. And then next up, we've got this one. P equals H minus 5 divided by 3. Make H the formula. So last but not least, we want to start by moving this 3. That's immediately in our way as it's in the denominator of this fraction. So if we multiply both sides by 3, we're left with 3p is equal to h minus 5. And then to get h as the subject or by itself, all we need to do is just add 5. So 3p plus 5 equals h. And there you go. Cool. So I hope that was useful. That was the Paper 3 Foundation for Edexcel in 2024. If you've got any comments or any thoughts on some of the questions and have any further questions, just fire them into the comments and I'll get back to you as soon as I can. Otherwise, have a look at some of the other videos. And yeah, I'm sure I'll see you around soon. Take care.